Good evening, students. Today again we are having a new lecture of aldehyde and ketones. Already I have completed in 5 minutes video. I have completed the physical properties of aldehyde and ketones. Now today we are going to discuss about the chemical properties of aldehyde and ketones. Okay, so be with me and focus. Chemical reaction. So, which kind of chemical reactions are shown by aldehyde and ketones if we are talking? So, they are showing nucleophilic addition. Nucleophilic addition reactions are shown by the aldehyde and ketones, like addition of CN minus, addition of OH, like that. So, first we have to talk about the carbonyl group. Check the carbonyl group, children. Here A, B, and that is the oxygen attachment. It's a planar species. It's a planar species, and this carbon is having sp2 hybridization. So suppose any nucleophile will come. So these electrons shifted here. This oxygen partial negative, this carbon partial positive. This nucleophile will attach with this carbon, and now it is converted into this kind of species, carbon and that nucleophile. Here A, here B, and here oxygen with negative sign. That step is slow step, so you can say it's a rate determining step. After that it is converted into, it will get one hydrogen, protonation can be done, then carbon nucleophile A, B, and it is OH. This type of species will form by the nucleophilic addition, and that step is very fast step. So from here carbon is converted into sp2 to sp3 hybridization state. sp2 to sp3 hybridization state. Planar to non-planar. Planar to non-planar species. First carbonyl group is planar species, and when nucleophile will attack, it is converted into non-planar species. So that is the reaction. So let's check other compounds, which kind of reaction they are showing if we are talking. So suppose we are talking about benzene. Which kind of reaction will show by the benzene, children? That is very important part. Electrophilic addition. Electrophilic addition reaction shown by the benzene. If we are talking about alkene and alkyne, so which kind of reaction they will show? Alkene and alkyne, they will show electrophilic addition. Sorry for the inconvenience. Alkenes and alkynes will show electrophilic addition. If benzene we are talking, then this is wrong actually. Benzene will show electrophilic substitution. Okay, so benzene will show electrophilic substitution. Rx, if we are talking, then Rx will show nucleophilic substitution. So that is the important part. Now come to the next one. So that is the chemical reaction explanation about the nucleophilic addition. Now addition of HCN. So here Cn minus and H plus. You have to identify nucleophile. Cn is nucleophile. How nucleophile formed? So check it. The formation of nucleophile. HCN reacted with basic medium. So from here Cn becomes free and water formation is done. Now check the carbonyl compound here hydrogen, double bond oxygen. So now what happened? Because of electronegativity, partial negative, partial positive, then electrophile will come and attach to the carbon species, and carbon here Cn, here CH3, here H, and here oxygen negative. Then simple protonation. How you do protonation? With the presence of water is present there, so from there it will get H plus and converted into Cn, CH3, H, and OH. So this kind of species is known as cyanohydrin. Cyanohydrin formation is done. Okay. So here children, one more thing we are going to discuss. We are going to discuss about the reactivity of aldehyde and ketones. So which one is more reactivity? If we are checking, then aldehydes are more reactive than ketones. Why more reactive than ketones? Electrophile attack is possible or feasible in case of aldehyde easily, in case of ketone not easily. So reason is due to less steric hindrance. Due to less steric hindrance. Due to less steric hindrance. Okay. So check it children. Here this is aldehyde, carbon, 3 hydrogen is attached. So this is aldehyde, and here we are forming CH3, CH3 ketone. So tell me one thing. Here steric hindrance less, here we are having more steric hindrance. So aldehyde is having more reactive than ketones because of less steric hindrance. Here steric hindrance less, here more steric hindrance. So one more thing, tell me one thing. In between benzaldehyde, in between benzaldehyde, that is your benzaldehyde, and alcohol and aldehyde, which one is more reactive? So again aldehyde is more reactive. Reason is for nucleophilic addition reaction. For nucleophilic addition reaction, aldehyde is more reactive, than aldehyde is more reactive than benzaldehyde due to resonance. Now check it, the resonance condition. Here what happened children? This is your benzaldehyde. Okay. Alternate double bond, C double bond, and hydrogen is attached. So these electrons shifted here, and this carbon is getting positive charge, oxygen is getting negative charge. So electrons supplied by the ring this time. Electrons supplied by the ring, because here pi electrons are present. Then these electrons shifted here, and these electrons shifted here. So because of this resonance, benzaldehyde is less reactive as compared to corresponding aldehyde. So let's solve some problems related to reactivity children. Question number 1, check it properly. CH3C double bond O, here H, it is A, CH3 CH, CH3 C double bond O H, and H C double bond O H, that is B and C. So what is the order of reactivity here if we are talking? Order of reactivity if we are talking, then what happened? See children, one thing you have to remember, rate or reactivity is directly proportional to positive charge on carbon atom, and positive charge can be decreases by plus I group, plus M group and plus R group. If these group present, then positive charge on carbon atom decreases and rate also decreases, and in between plus R and plus I, plus R decreases more. So this basic concept you have to follow. See, so now here this is showing plus I effect, this also showing more plus I effect, and here no effect. Then what is the order now? Which one is more reactive? C, then A, then B. That is the order of reactivity. Let's discuss one more question. Number 2, CH3, C, CH3, A, here benzene ring, C, and here CH3, option B, benzene ring, C, option C. These are the compound. So check it children, which one is more reactive here. So here we have to find out plus I, here plus R, and here plus I, and here plus R, here plus R. So what is the order? A, B, C. Simple. A, B, C is the order, because I told you R impact more, dominant I, R dominant I. So then A, then B, then C. Third question is very important children. Many times whatever questions we are discuss here, definitely they comes in different exams previously, and as per the new exam point of view, next exam these questions are important. So here the question number third is very important. A, B, C. Here plus I, plus I, plus I, and this is plus R. So A, then C, then B. That is the order. So we solved 3 questions. Now come to the next chemical reaction. Chemical reaction number 2, addition of NaHSO3. So check it, this reaction, this is also called aldehyde. Reaction number 2, sorry, addition of NaHSO3. This is also called aldehyde ketone test. You have to identify, if two solutions we are having, which one is aldehyde, which one is ketone. See how to identify. So here CH3 CH double bond O, and here we are having NaHSO3. So sodium is positive and this sulfur is negative. Electron transferred here. So this is having partial negative and this is partial positive. So what happened? Positive charge attached with this and negative charge attached with this. So what happened next? Carbon, hydrogen, SO3H is attached, and here O minus and Na plus is attached. Next step, very simple, only you have to perform H plus transfer. What you have to perform? H plus transfer. H plus transfer. So this H will attach here and sodium will transfer here. So what you are getting now? Carbon CH3, here H, and here SO3 Na, and here OH. So this is a formation of white crystalline solid, white crystalline solid. So if white crystalline solid formation is there, that is water soluble, that means substance is aldehyde. So why attachment from the sulfur side only? Check it once. Here Na plus O minus sulfur OH double bond O, and sulfur is having lone pair. That is why attachment done from the sulfur side. So that reaction is completed. Come to the next one. Reaction number 3. Addition of alcohol. In the case of alcohol, R-OH, H is positive, RO is negative. You have to identify nucleophile. That is very important part. What is nucleophile here? Alkoxide ion. RO minus is your nucleophile. So check it, children. CH3, here H, double bond O, reversible reaction. These electrons shifted over the oxygen, partial negative, partial positive. Here we are having ROH, H positive, RO negative. So negative part attached with this, and here H plus attached with this oxygen. So what we are getting? CH3, CH, here OR, and here OH. That intermediate form, and it is a very famous species, hemiacetal. Hemiacetal formed, name alkoxy alcohol. It is alkoxy alcohol. Then one more alcohol unit we will use H plus minus. This oxygen is having lone pair. Then H plus will attach with this oxygen, and what we are getting now here CH3 H, here OR, here O, oxygen is positive charge because it is accepting H plus, and here this H. Now the very simple process, entropy also support, it will take electron and water species will leave, and RO is free from here. That RO will attach with the carbon because carbon is getting positive charge now. So ultimately you are forming CH3H OR OR. It's called acetal. Acetal formation is done. Gem dialkoxy. Gem dialkoxy. So this is the chemical reaction of addition of alcohol. There is no mechanism required. Whatever possible mechanism is there, that I have already explained. In that case, one more equation is given in NCERT. That also we have to check. Same CH3 C CH3 double bond O plus HO CH2, here CH2O and H. So what happened? These electron transferred here, this oxygen lone pair, so that H plus will attach with this oxygen and removal of water molecule will be done. Two hydrogen is there, one hydrogen, this one hydrogen. So you have to write it CH3CH O CH2 CH2 O like this. This product will be formed. What it's called? Ethylene glycol ketone. Ethylene glycol ketone formation is done. So this is all about the addition of alcohol. Thank you. Thank you, children. Please follow us, subscribe us. We are working very hard for you people. So please, children, subscribe our channel, and for the regular update, watching Chemistry Guru. Thank you.